In this video we're going to talk about two theorems, the Remainder Theorem and the Factor Theorem. The Factor Theorem is a resulting theorem of the Remainder Theorem, and the Factor Theorem is used exclusively in the rational zeros theorem, which you'll study about in pre-calculus and also use in the calculus courses. With the Remainder Theorem we use something called synthetic substitution to find remainders. Basically it says if a polynomial function f of x is divided by the binomial x minus c, the remainder r is the value of the function f evaluated at c. And the way we find it is by doing something called synthetic substitution. So an example I have here is find f of c, the function f evaluated at c, if the function f of x is x to the fourth minus 5x squared minus 17x minus 12 when c equals 3. Now before, in an algebra class, what you would do is wherever you would see an x, you would replace it with c, which is negative 3. In this case, since we're using the Remainder Theorem, we will use synthetic substitution here. So what we'll do here is we'll take our beginning division, we'll use synthetic division, and apparently my blue pen doesn't want to work today. We'll take our value of c, which is negative 3, put it in that little box there, and then we'll write the coefficients of each of our terms in our function. Coefficient of x to the fourth is 1. Notice we don't have an x cubed term here in between x to the fourth and minus 5x squared, so we need that placeholder of 0. Next is negative 5, then negative 17, and then negative 12. Draw a line, and there you go. Alright, like you did, but like what you would normally do. Okay, let me test my blue pen. See, it's still being a little odd. So what we do, we perform synthetic division like you normally would. Drop the 1 down for 1. 1 times negative 3 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3 is positive 9. Negative 5 plus 9 is 4. Negative 3 times 4 is negative 12. Negative 17 plus negative 12 is negative 29. And then negative 3 times negative 29 is a positive 87. Negative 12 plus 87 is 75. And this value right here, what would, alright, that's our remainder, right? That's our remainder. Is the value of f of c. So this value of f of c, or f of negative 3, is equivalent to 75. And you could check this by doing f of negative 3 equals negative 3 to the fourth minus 5 times negative 3 squared minus 17 times negative 3 minus 12. You could check it that way, and you would still get 75 out of it. Right? Now, that's basically what the Remainder Theorem says. Now, there is a special case of the Remainder Theorem, which is called the Factor Theorem, and that's when this remainder is 0. So let's do a quick example to test whether a factor is, whether a certain binomial factor or term is a factor of a polynomial function. All right, so the example that I have for you, right, that uses the Factor Theorem says is x minus 2 a factor of f of x equals 2x cubed plus 5x squared minus 14x minus 8. Now the factor theorem, just to reiterate, says x minus c, that binomial, is a factor of the function f of x if and only if f of c equals 0. If and only if, by the remainder theorem, we get a remainder of 0. So, synthetic substitution here. To test if x minus 2 is a factor, in this box here we take the opposite of negative 2, which is a positive 2, and then we write our coefficients. Notice we have a cubed term, squared term, linear term, and a constant, so we don't need any placeholders, we don't need to put in any zeros. Coefficient of x cubed is 2, coefficient of x squared is 5, coefficient of x is negative 14, and we have our constant negative 8. Drop the 2 down. 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. Negative 14 plus 18 is 4. 2 times 4 is 8. Our remainder here, negative 8 plus 8, is 0. Since we have a remainder of 0, so since the remainder is 0, then x minus 2 is a factor of the function f of x. If you do this synthetic division here, the synthetic substitution here for the factor theorem, and you get anything other than 0 as your remainder, that binomial will never be a factor of the function f of x. Okay, so using the factor theorem to determine if something's a factor, you want a remainder of 0 here. And believe it or not, this factor theorem here comes into play in something called the rational zeros theorem, when you're asked to solve for all the factors or find all the zeros of a polynomial function. So that's the remainder theorem and the factor theorem. In short, they all use polynomial division and either synthetic or long division. Again, synthetic is kind of the shortcut to doing it. The only thing that's funky is if we have a term that doesn't have, where the x term, the coefficient of x is not 1, you need to use long division to solve that. So, again, that's the remainder theorem and factor theorem. Have a great day.